Hello and welcome to another Orange Coast College mathematics video. In this video, we want to look at graphing inequalities on the number line, set builder notation, and interval notation as a way to write down sets of real numbers. Now, before we begin, it's important to talk a little bit about set builder notation and interval notation. So for each one of these examples, on the left, we have interval notation, and on the right, we have set builder notation. So the way we often write set builder notation is we say what an element of our set looks like, and we give restrictions for those elements on the right of this bar here. So what we say here is x, and we say x such that x is between a and b. But more than that, it's strictly larger than a, but it's less than or equal to b. Now, if I want to write that in interval notation, I write that as the pair of endpoints. So A to B. Basically, I want everything from A to B. We use a parenthesis to denote that we're not including A, and we're using a bracket to note that we're including B in that set, right? Because in this set, B would be inside of this set. It would be included, but A would not be, since we are only looking at elements that are strictly larger than A. If we want to have an open-ended interval, so in other words, everything larger than A, so all x such that x is strictly larger than A, then we can write A to infinity. Okay, and we use a parenthesis here to denote that A is not included in the set. And since infinity is not a number, we always use a parenthesis there because infinity is not included in our set. Okay, it's important to note when you write down interval notation, the number on the left should always be smaller than the number on the right. Let's do an example. So here we have three sets written in set builder notation, and we want to graph these on the number line. So the way we do this is by simply, I'm just going to draw a line over all of the values included in this set. So this is all of the x, and we usually might write x in the real numbers, something here, but we can write x if we assume we're talking about the real line. All x such that x is less than or equal to 2. So on the number line, anything that's less than or equal to 2 is to the left of 2. So what we'll do is we'll just draw on the line, I'll use red here, everything less than or less than 2, anything to the left. Now, since we're including the point 2, since it's less than or equal to, 2 is in this set. So the way I denote that is by drawing a closed circle on 2. Okay. For the next one, same idea here, x such that x is larger than 1. So larger than 1 is anything to the right of 1. So I'm going to graph to the right of 1, and you might just graph the arrow like that. I didn't do it up here, but you can draw the arrow too, just to denote that it goes off in that direction forever. Now, in this example, we're saying x has to be strictly larger than 1. So 1 is not included in this set. So what we do to denote that is we're going to draw an open circle on the 1. So just make it an open circle like that. Finally, in our last example, x such that x is greater than or equal to -3, but less than 8. So greater than -3 would be anything to the right of -3. Less than 8 would be anything to the left of 8. So we don't have 3 on this number line, but we can assume it's between -2 and -4. -3, I should say. So since we include -3, I'm going to draw the dot. That's where -3 would be. And then we want anything larger than that, but not including 8. So we draw the open circle around 8. And that's how we graph these. To write them in interval notation, I just say what is the left endpoint of this set and what is the right endpoint. The left endpoint, since it goes off into infinity, writes everything less than 2. The left endpoint would be -infinity. We always put a parenthesis on infinity or -infinity. And the right endpoint would be 2, and we use a bracket so that we know that 2 is included. For the next one, what is the left endpoint of this set? The left endpoint would be 1, and we use a parenthesis since 1 is not included. And since our set should go all the way to the right, by which we mean infinity, the right endpoint is infinity. And then finally down here, the left endpoint is -3, which we use a bracket since -3 is included. And the right endpoint is 8, which we do not include, so we use a parenthesis. And that's it. I will say sometimes, instead of using the open circle or closed circle, You might see examples in your textbook where they use a bracket here. So you just put a bracket for including the point, and you might put a parenthesis if you were not including the point. Okay, in this example, we want to write each of these sets in set builder notation and graph. So first thing first, I want to graph just so we can see how we graph using interval notation. So our left endpoint is 3 and our right endpoint is infinity. So basically we start at 3 and we go all the way to the right to infinity. So since we're including the point 3, you can either put a closed circle here, or I'm going to draw a bracket like I said in the last example, and then you just graph off and to the right. So obviously our number line has to stop because we can't draw it going forever to the right, but you can just put the arrow in to denote that it goes on forever. Okay. For the next example, for B here, we want to do from -1 on the left to 4 on the right. Okay, so since we have a parenthesis, we're not including -1, we're going to put a parenthesis there. And then at 4, we are including it, so we'll put a bracket. And then we just want everything in between those two numbers. So we graph like that. The last one, our left endpoint is -infinity, so that's all the way to the left on the number line. And our right endpoint is -5, which we use a parenthesis there, since we're not including -5. And again, we just graph everything to the left of -5. And I'm going to put the little arrow there just to denote that we are, in fact, going on forever in that direction. Okay. Now, as far as set builder notation goes, you have to convert this interval, or your picture in here, into an inequality. So it's always going to start the same way. You use these curly braces, and we say x, and then we draw the bar for such that. And after that, it's just about figuring out what is the inequality. So for here, it's x is going to be, this is everything where x is greater than or equal to 3, right? Everything to the left of 3 means greater than or equal to 3 in this case. So that's it for set builder notation for that one. For the next one, again, it always starts the same way. You write the curly brace x and then draw the line for such that. And now we want to have everything that's to the left of -1, but to the right, or sorry, to the right of -1 and to the left of 4. So everything that's bigger than -1. So x must be larger than -1, strictly larger. But it has to be less than or equal to 4. And so that's all we have to do there. And for the final one, again, it always starts the same way. We write x such that. So it's everything to the left of -5. That's all the numbers that are less than -5. So we write x less than -5. Now remember, for set builder notation, again, this is what your numbers look like, and this is the restriction on those numbers, like x such that x is larger than 3. So all the numbers that are larger than 3, okay, or equal to 3. In our final example, we have only the graphs, and we want to write the set that is indicated by these graphs in both set builder notation and interval notation. Now, which one you do first is entirely up to you. For the first one, we have all of the numbers between -8 and -3, including -8 and -3, right? Since we use these closed circles, that means that we want to include those endpoints. So the left endpoint, if we're doing it in interval notation, the left endpoint would be -8 included. The right endpoint is -3, which we also include, so we use brackets. I can also write it in set builder notation. It's all numbers x, so that x has to be greater than or equal to -8, but less than or equal to -3. It's important to note that these are the same sets. These two different ways of writing it. We are writing down the same collection of numbers, but just different ways of notating it. Okay. So for B, our arrow goes off all the way to the left. So that means our left endpoint would be -infinity, and our right endpoint would be 3. So I'll write this in set builder notation first. So it's all x such that we have everything to the left of 3 is included here. So that's everything that's less than 3. So you could write x is less than or equal to 3. Since we used a closed circle, we mean we include 3 in that set. If I want to use interval notation, the left endpoint would be -infinity, and the right endpoint would be 3. We use the parenthesis on -infinity always, and since we're including 3, we use a bracket. Finally, for the last one here, our left endpoint is 2, and our right endpoint, since we go all the way to the right, we call a red arrow there, we are going to have our right endpoint be +infinity. We do not include 2 in our set. Since we have an open circle, that means we have a parenthesis here, and we always have a parenthesis on infinity. So it's 2 to infinity, not including 2. Okay. With set builder notation, I can write that as all x, such that, so we have everything that's larger, everything to the right of 2 is everything that's larger than 2. So x is greater than 2. And that's it for this video. My suggestion is try to figure out what is the left endpoint of your set, what is the right endpoint, and whether you need to graph it, that will help you graph it, whether you need to take the graph and turn it into a set, whether it's interval or set builder notation. Identifying the left endpoint and the right endpoint will be 90% of this problem. All right, keep practicing. Until next time, have fun.